Cool. Let's start. Just give me a
Yes.
second. Can you see my screen?
Yes, Chakshu, we can see your screen.
Cool. Uh, okay. So what we'll do in this session is we'll continue what we were building earlier and see the kind of progress that we made. This is about me. We can skip. We can skip this as well. Let's just do a recap on cohorts mindset. We want to facilitate structured sharing of resource materials, which is something that we'll share in this session as well. You want to build in public. If all the code that we are doing is going to be shared publicly. You want to build a safe learning environment. As in terms of members' mindset, we want highly driven code writing people uh, because this will be a hands-on exercise. All of the tutorials are all hands-on. We want to have academic integrity, and there is a week by week plan, resources, books. All of this is okay. Cool. We can start with this status update. So over the past 1 week, StylusDB has gone through a lot of changes. I'll just go through them one by one. One is we have completed all of the steps that we set out to do. So it's now step 1 to step 20, all in tutorials. You can just go through them, work alongside those tutorials to actually grow your skills in building a parser, an executor, and a combined DB along with the storage. The next thing is it now has an updated docs. You can go to the site. Let me just share this tab as well. You can go through the entire thing, and it's well documented now. Sharing this tab. Yeah. Moving forward, what we've done is we have also published this to npm. So what you can do now is you can just do npm i StylusDB SQL, and you should be able to start using it. You don't even have to fork the code to actually use the database. You can do this directly now. Moving forward, it also has its own server now. What we have done is we've taken inspiration from Postgres and we run on the same port 5432. Given none of the Postgres people will be migrating to StylusDB at least for now. Yeah. Cool. Moving forward, it also has like a JavaScript client. You can see it connects and just exposes a lot of logs. Um, so as you can see, it tries to attempt to connect to the server first. It gets connected, then it sends a query, it receives a response. The response is printed here, and so on and so forth. So if a query cannot be parsed, it will say invalid select format, and so on and so forth. Okay. Right. Moving forward, it also now has a demo website. It's not deployed yet, but what you can do is you can see a terminal here on the website itself. So you can play around with this website on your local system, and it works like a terminal. All you have to do is type in StylusDB CLI, and it will start a CLI in your browser, in which you can just play around with the database as well. Okay. Um, right. Moving onto the main objective of this exercise. What we are going to do is we are going to deep dive into how we can connect an ORM to StylusDB. Although the population is a little thin, can everyone who has gone through what an ORM is? We'll go through it anyway, but please raise your hands if you went through the link that I shared earlier. Okay, yes. Anyone else who went through the Wikipedia link? It's not a problem because I'll be covering that anyway. But yeah, cool. I think we can proceed. So the first thing that I want to share is Can anyone guess what this image is doing right now? You can type it on the link as well. But yeah, can anyone understand what this image depicts? So this depicts an ORM, but can someone describe what it is doing? You can paste it in the chat as well. Yes, you went through the ORM, so do you want to take a crack at it?
Yeah, I think it is showing how the data, a row in a table, is being mapped to an object inside a programming language. Let's say a JSON object inside JavaScript.
Yeah, Ria, do you want to share something?
Sir, I think what Yesha said.
Right. So it's not just that. So as you can see, the arrows are some of the arrows are bidirectional, some of the arrows are unidirectional. So also, if you see on the left hand side, there is a single object on the left hand side, which is mapped to two rows, two tables, two different tables. Okay. So what an ORM would do is it would pull all of the data, all of the rows from your database, and will create an object in any of the programming language that you're working with. Okay, and then you can just use those objects similar to how you use any other objects. So what it does is you don't have to write SQL queries, or even if you're writing SQL queries, in response, what you're getting is like an object that you can play around with. Okay. The bidirectional sense means that the representation on the left hand side also gets also updates the database on the right hand side. So if an ORM has a responsibility to update the tables in the database, and if the database tables are updated, you should be able to get a updated object relational mapping on your schema as well, on the programming side of things. So it gives a bidirectional connect, which is something very unique that I've seen. It's a very good programming pattern. It has lasted over the last 30 years. So as soon as SQL came out, there were a bunch of ORMs already, and they're still like a large breed. So if you see every year, like hundreds of ORMs would come out, and this is something that we'll see later as well, and we'll see why this is useful moving forward. 1 second. Yeah, moving forward, why would you use an ORM? Because you're able to use an object rather than SQL in code. Which is not native. So SQL is a foreign language. It's a querying language. What you write code is let's say in Java, in Rust, Go, whatever. But you don't write code in SQL, right? So you would rather use an object which you can directly get out of a database. It also reduces boilerplate code. It manages connections. It manages pooling. It manages how you write SQL and so on and so forth. So a lot of this SQL code that you may have to write gets reduced. It's also a database abstraction. So it's exactly a mirror. So it's an abstraction over and above of SQL itself. So you're not using SQL anyway, and you only use parts of the SQL that are exposed through an ORM. So that database abstraction is useful in the case where you may not want to expose all of the SQL. Okay. In terms of security, given that you're not writing SQL, it is always generated. The SQL injection cannot happen, right? In terms of data consistency, similarly, you can look at how it simplifies queries, and this is something that we'll get into as well, on how to manage transactions for this, and so on and so forth. It also allows you to build composable code. So if you have like 5 queries, you can convert them to objects. You can write functions, higher order functions, and higher order functions, and you're able to do composable code similar to how how you do it in object-oriented programming. A lot of people hate ORMs as well, mostly because the object relational mapping is a very hard problem to solve, and no one has done a very good job of it. So it's still an unsolved problem, as I would say. There is a performance over it because you're doing an additional compilation at the very object to SQL itself. SQL has also evolved over the last 30 years, so using SQL you are able to do far more. It's a very large specification. It's around 1,200 pages of specifications that SQL has built. So yeah, it's a very large specification. You can do a lot more than what you can do in an ORM. An ORM will never be able to catch up to what SQL is doing. In terms of leaky abstractions, I don't know if you have heard of Joel Spalski, who coined this term. So leaky abstractions mean that whatever the abstraction below, let's say database is the abstraction below, and you're trying to hide database through ORM, you're not able to do it perfectly. You'll always have to know how database works to be able to use an ORM per se, and that's what leaky abstractions are. Some people don't like it. There is limited control and flexibility of the database. Any ORM that you build will always provide you with a subset of the queries that you can do through SQL. So people feel that there is not much control that they are getting. There is not much flexibility that they are getting. So they're losing out on a lot of fronts. And that's why they don't want to use ORMs at all. There are a lot of potential for bad practices. This is for the ORM builders. They don't use the best practices. They simplify. They simplify the process so much that people learn bad practices anyway. A good example of this is in Django ORM. You can do any number of joins, right? And it has such a high performance issue that they have to write an additional page on how to speed that up. Okay, and that's just one of them. I can give you countless examples where an ORM has led to people not knowing the inherent table itself, and they were not able to figure out how the database was structured. So because they never saw the database itself, they never saw what kind of tables are built. If you're doing a many-to-many mapping, you don't know if there is an intermediary table or not, because it can happen in both cases. But there is generally always an intermediary table that is created. You'll not know unless you actually go into the database, because the ORM will just say that create a many-to-many field. It's simple API over this. And there is a very beautiful article by Martin Fowler on why people hate ORMs. You should go ahead and read that as well. What are the solutions? There are two different ways in which you can get away with it. So if your application is extremely simple, so that it's just a CRUD application and you don't have to manage relational mapping in itself. So you have different swim lanes of CRUD apps that you build. Then you might as well not use an ORM, right? Or use a very simple ORM, and that's something that you can do. It simplifies the process so much. But yeah, not every domain can be mapped in a similar way. Or you can just, if you have like complex relationships, you can directly use it. You don't use a relational database. You can use a NoSQL. You can use a KB. MongoDB is a very good example of how to get away. And let me tell you, MongoDB may have launched recently, but this entire thing about moving away from relational databases started in the 90s itself. So it's people have been thinking about this problem for the last 30 years, that ORMs are not good and we should move away from them. They don't, or more importantly, SQL is not good enough for them. They want something more simpler, which is what MongoDB provided when it came out, right? In terms of uh, the ORM that we'll connect with our database, we'll be connecting Prisma. Prisma is a JavaScript-based ORM which allows you to create simple database schema, something very similar to how you would create an object. As you can see, there is an object for database, there is a model for post and user, and so on and so forth. So, and you're able to build relationships like just by writing at relations. So this, a lot of people find this far more simpler than what a database schema management would look like. So what we'll do is we'll show you how this now works with StylusDB as well. Right. Prisma also allows you to build types, which in itself allows you to do autocompletes. So as you can see, when in this example we are trying to do like a where title, all of these will automatically come up, mostly because the client is auto-generated, and it will have all of these types. That title can have like contains, ends with, equals, greater than, equal to. Okay, all of these clients are defined by the type of schema that you have. So mostly Postgres and MySQL have like a very high overlap. So even if you pick any one of them, you'll get a very good client straight out of the box. It is also a type safe database, so it will not let you insert something that is, and it will just flag it upfront as well, that you cannot add like a string in a Boolean and so on. It also provides you with a visual database browser, which is something that we'll showcase in future sessions, that StylusDB can be seen through a visual GUI tool. Your own database being showcased as something that you can just go ahead and change, essentially. Moving forward, what we are planning to do is we are planning to build an adapter. What an adapter does is, so this is a general way in which Prisma works. So what you have is a Prisma client, which tries to connect to a query engine. It will send queries with an ORM. So this is an ORM related query. Find many is not SQL. The query engine will convert find many to a SQL, and the database would return a response with the SQL response. So this is how any general ORM works. When you send connect, it will connect. When you send close connection, when you send disconnect, it will close the connections also. Okay. Cool. Let's straight away get into the code of things. What I was able to pull off was I was able to create like a Prisma adapter here, which you can go ahead and install through npm install, so on and so forth. I've also exposed our database on localhost 5432. As you saw earlier, there was a server there. So what all you have to do is just put in the database URL as 5432. Set up your Prisma schema, something like this, something which you have already done. So we had like students and enrollment as two tables. These are connected similarly as well, right? And then all you have to do is you can just set up your connection like this. Put in a connection string. You are create a connection object, create an adapter, create a Prisma client, and then you can start using this client to actually make some queries as well. Let me just go ahead and I think this is some issue with. So you just need to see this. So you need to create a client, then adapter, and the Prisma client, and then you can start doing queries like this. So Stylus SQL is now able to do queries like prisma.student.create, data name, age, and you'll see this working by adding this to the CSV as well. You can also do queries like students await prisma.student.find many, and this will also work straight out of the box. Okay. Prisma.disconnect also works, Prisma.connect also works, and so on. Okay. We still don't have transactions on StylusDB, so we'll get to that as well. But yeah, those are coming soon enough. moving back. Right. So where does this fit in? So generally, what you do is you create an application backend, something like a Django or a Next.js or whatever your application backend may be. You connect through an ORM and you do a schema management. So this is something that became green for us, or rather red here. But yeah, what we were able to do was we were able to create like a proper instance of a ORM to allow you to manage your database through a client communication and then parsing queries and so on and so forth. So this is the additional things that we have done, and we'll get into how to make all of these other blocks green too moving forward. But yeah, for now, this is where we are in the entire scheme of things. Right. Let's straight away start with the code on how the server looks like. Server has a simple implementation. The server has a simple implementation. It accepts a single connection from a client. It rejects any other clients because we are not creating a multi-threaded implementation of a server. It's a single-threaded implementation. What the next thing that we do is we do in order execution. So we manage a queue. We execute queries one by one. We don't do them in parallel because what would happen is if you start doing them in parallel, a query which is at index 0 may take longer than query which is at index 1. And if there is an insert query and then a select query, it will start causing an issue. And if there is an insert query and then a delete query and so on and so forth. So there could be multiple combinations that will become bad for us. So what we've done is at the very start of it, what we have kept is we'll do in order execution. We'll not change the order, and then we'll figure out how to make it work. Which queries to actually can be pipeline and do it much better. This is something that will come later in the series. But yeah, for now, we've kept it in order execution. What we've done is we also use native socket API, which is a wrapper over Linux sockets. If you haven't gone through them, it will come in one of your courses later. But yeah, we are using the native socket API. And let's just dive into the code as well. Can you guys see GitHub right now?
Yes, Chakshu.
Cool. Right. Yeah. So what I've done is I've created a query queue. As I said earlier, it allows you to add a queue, add a query. It allows you to process the queue itself, and it allows you to execute a certain query. Okay. What executing means is if it is a select query, go to execute select query. If it is an insert query, then go to execute insert query. If this is like a delete query, then so it's a simple if else case. It figures out which query it is and then redirects it to that kind of a thing. So if it is a query that we don't support, we'll just say unsupported command. I'll come back to the process queue later. But essentially what it's doing is it's managing the entire queue, and it does a shift or dequeue essentially whenever query is executed, and it actually calls the execute query and then does the entire process. Okay. So this is my queue. I'll just hide that right now. I create a global queue. Okay, so this is my global file. I create a global queue. This was just a class. This is an object, actual instance of the queue. Whenever I'm getting a query, okay, whenever I'm getting a query, this is my query. This is how I'll send my query. I'll divide this into two parts. One is a query ID colon the actual query. So if I have like a specific format in which I'll get a query, so I can divide that into two parts. I can get the query ID and the query itself. I can execute the query, and then I can return the response in a similar format. I'll put in a query ID, I'll put in a separator or delimiter, and I'll return with the response. Okay. So this is a very simple implementation. This is an error message. Sorry, this is an actual query. Yeah. Right. What it also does is it also checks if there is only one connection alive, because as we said, this is a singleton. We are not creating multiple connections, or we are just denying multiple connections. You can obviously create one. You can remove this, and you can see abnormalities happening when you send multiple requests from multiple clients. So this can happen, but yeah, this will come up later, so that you may not lose out on managing multiple connections. Okay, this is a speed hack that we'll start using later on. When you close, you just say that the active connection is closed now. It's just a flag, and then you'll allow for more connections to happen. Okay, right. One second. Let me just move back to my presentation. Moving forward, I also created a client. Let me just go through the client now that you know that the server exists like this. This is how the client looks like. What you have is a socket itself. You connect two sockets, you send in your queries, and then you get a response. When you're sending in a query, what you'll do is, 1 second, let me just, yeah. So when you send in a query, you create a query ID. You send in a query in the similar way that we shared earlier, that there will be a query ID and then there would be query in itself. That this is a promise-based async await kind of a setup, which I'll show you how that works. But yeah, this is how we have wrapped socket connection onto a promise resolve reject construct. So you can now async await the client itself when you're executing something, and we'll show how this got utilized as well. Right. So this is like a simple implementation. You can go into the depth of this and raise issues if you find any issues around how this is working. Right. Moving forward. Right. So essentially, what we have done is we've created a database driver. Okay. So this is already generated. Prisma client is already there. There is already a Prisma query engine which will convert find many to a SQL query. Now this is where your StylusDB lies, and what we are doing is we are pushing in the SQL queries through a database adapter. So this is like a dependency injected into the query engine, where I can do custom modifications to the actual query. Okay. Sorry, what was I sharing? Was I sharing the presentation?
Now you're back to the presentation, Chakshu.
Now, oh, got it. Sorry. Yeah. I'll just repeat this again. Sorry, my bad. So when I'm actually implementing this, what I'll do is this is already generated. Prisma client is already generated from my schema itself. Then there is a query engine which will convert find many Prisma.user.find many to an actual SQL query. That SQL query will then go from 2 to 3. It will go to the database. There would be a query response. I'll reformat the query response to the format in which the query engine accepts it, and that will be it. Okay. Right. So it's a simple dependency injection that we'll do later. So let's just get into how the database driver works in itself. Right. Moving to this. So what I've done is I've created like a queryable, which allows me to do raw queries. Okay, so this is the most basics of things. So sending a SQL query. What you do is you execute that query on StylusDB and get a response and format that response. How that response is formatted, I'm converting them to Prisma results. With the Prisma result set for an insert query. Similarly, I'm converting them for select query. If I have like a delete query, if I have to actually upgrade this implementation, I'll have like a delete query and some other types of queries as well if we get to that, like a set table and so on and so forth. Right. So what we have is a query raw, and then essentially what it does is it will it will use the client to actually send in the query as well. So this dot client dot execute, the same function that we discussed earlier, this is getting used here itself in the adapter. So we created a client first, and then we use that client to run that query in an adapter. Okay. Then there is a transaction, which is something that we haven't delved into, and this is the final object. You don't have to worry about this, but this is the object that you utilize. This is the main function that we export, which is just a wrapper over all of these functions. So this is extended by a transaction. Then this is an extension to the actual transaction, and so on and so forth. So as you can see, there is a hierarchy around all of this, and this is something that we use in general. So what I've done is I've not created a transaction. Okay, this is just a dummy function here, but I can still execute the query itself. This is just extension of classes that you generally see in object-oriented programming. Okay, there are some query utilities that I've added. What it does is it removes some of the things like public, because we don't have a schema per se. So we don't have a public schema in our database. All of the database have schemas. So I'm just removing all of that. I'm also removing, so Prisma has this, Prisma adds this noise that whenever you do a select star, it does where 1 is equal to 1. I don't know why it does that. I'll have to get a little deeper into that. But for our database, you can do select star. You don't have to write where 1 is equal to 1 for StylusDB. So what I've done is I've removed that. Similarly, offsets are something that I'm removing because we are not supporting offsets right now through our Prisma adapter. I also removed some of the other kachara that comes in through Prisma itself. Okay, and then we just send a clean query to StylusDB. What we are also doing is we are also converting, as you must have seen, a select query output to whatever Prisma expects. Okay, so this is what Prisma expects. You can get into a little deep into all of this too. Similarly, you can get deep into how insert query. So insert query will have like a last insert ID. This is something that we return from StylusDB now. This is an addition that I did in StylusDB to actually do queries like returning through inserts. Okay, right. So this, in terms of the structure of the entire repository, this has also changed. So now what we have is, earlier what we had was docs. What I've added is example. So example includes a Prisma based example, or what you can do is you can use like an older example with just the simplest of clients. So what you can do is you can just connect your client like this. You don't have to use Prisma for everything. Client.execute, and then you'll get a response. That's it. That's all that you need to do. So this also works right now. Okay, so this hasn't gone away. This is the simplest of ways to actually use StylusDB. Yeah. Yeah, I would recommend you go through the code, and because I don't think we'll be able to cover everything in an hour. There is a lot of movement that has happened. So what I'll do is I'll share specific details around the code by documenting this a little more, and then we can get into because I would want you guys to actually do it. I don't want to spell out everything. Right. So this is there is an example folder here as well. Then what I discussed was there was a demo as well. So demo is just there is a server client set up here as well. So on the front end, all you have to do is just see index.html. Index.html is importing a frontend.js. A frontend.js is nothing but a connection to a WebSocket, which allows you to run the CLI itself. Okay, so if you have not seen the CLI, you can go ahead and see the CLI as well. CLI is nothing but a simple Node.js read line wrapper, which allows you to see if if this is a select query, then execute that query. All of those same things that we are doing in the server client setup, we are doing it here as well. So we are just routing them through if-else clauses. Okay. I've also refactored the tests. So now there are tests which include CSV readers, delete executor, insert executor, query executor, which is the older select executor, and there is a query parser which hasn't changed. Okay. The web has demo anyway, which is something that I discussed. Prisma/Prisma adapter has the actual adapter code which you can install and see it running. Let me just go ahead and show this as well. I'll share my screen. Can you see my editor? Right. So what I've done is,
Yes, Chakshu.
so what I've done is I've linked my npm run build. So whenever I make a code change, I'm able to. So I don't have to do npm install the Prisma adapter again and again. So all I have to do is I can just do an npm run build, and then it automatically gets linked, because I was changing the code so much for Prisma adapter that I had to do this. I'll just go to the example. I'll go to Prisma. There's a package.json where you can just test this out. Let me just do that. Yeah, let me just open a new terminal. CD examples. I'll have to go to Prisma. Okay. I'll have to start the server first. Let me just restart this npm run server. And this is my Prisma. Npm run Prisma. Okay. So as you can see, it just ran the entire thing. Given it's a database, it's extremely fast. So as you can see, it sends in. Let me just go through the code as well, along with what's happening. So the first thing it will try to connect to the client. Okay. Which it tries to connect. Client constructor called, attempting to connect to a server, successfully connected to a server. Okay. And then query raw is getting called. So I haven't removed the debug logs so that you guys can follow what's happening here. Then what happens is it does a raw SQL query. So as you can see, I've done select ID from student. So select ID from student is the first query that gets executed. The response is just a list of IDs 1, 2, 3, 4, 5. Then I've console logged the raw query data as well, which is what you see here itself. Okay, so raw query data, the output as a JSON object is getting rendered here. The next thing is to actually do like a create statement. So different APIs. So the idea was to showcase different APIs of Prisma getting run through the Prisma adapter and showing you the outputs. Okay, so if you see prisma.student.create now works as well. All you have to do is just write any valid query in Prisma, and it should work out, as long as I've implemented that in the adapter. But yeah, it should work out. So what it does is, if you see this entire query generates a query called insert into student name age values this, returning student.id, student.name, student.age. So this is the actual query that gets generated out of this, which is something that Prisma is doing. And what I'm doing is executing this query into my own database and returning a response. So the database will return a response like this. Okay, row inserted successfully, inserted ID 6, returning is this. But what you see in Prisma is this. So I convert this structure to this structure, and that's what the longish. Let me just go through that as well, and you'll see it on the right hand side. Wait, I opened the wrong file. So if you see this convert to Prisma result set insert query is doing this transformation, this query to this actual query, and this is something that I'm printing here itself. Okay. Then there is a last query called await Prisma student.find many, which gets converted to select ID, name, age, because you're not doing anything. So it will pick up everything from the schema itself. The schema is mentioned here. So student has 3 fields: ID, name, and age. So it's selecting everything. So find many does that to you. If you go to this, it will show you that it takes in all of the external args. Sorry, it takes all in the additional parameters that are there. Okay. Right, and then I console log the student. So what you see is this is what I'm getting from the database. Okay, which is a string ID, string ID, string ID, and this is what you're getting out of a Prisma query. Okay. The next thing that I'm doing is just disconnecting from the database itself. All right. I'll stop sharing. Go back to the code. Go back to the presentation. Right. So what you have seen is an end-to-end Prisma running. The next steps are something that we'll discuss, and these are some of the assignments that you guys can take up. There are a lot of them actually. So we want to make StylusDB at least 60 to 70% schema compliant, and let me just show you what that means. Test. So this is a public repository that has converted the SQL schema standards 2016 to somewhere around 1400 queries. Okay, and they maintain how much every database is how every database is doing. So let's say a Postgres 9.2 is able to run 1196 queries. So and this is still 82% only. So these are all of the features, 135 of features out of 152. And this is something that we also want. We want StylusDB here, and we want to showcase that we are also doing, like, let's say 20, 30, 40 features and somewhere around 300, 400 queries that we are able to resolve. So that's how it will expand. We'll start measuring how much support that we can do for SQL, and then continue evolving this. So this is one place where I'll need some help, because I don't think I can do all of this alone. That's where. So this is on the integrating global test and track SQL spec coverage. So what I'll do is I'll set this up so that you can always see in every commit if you are improving the SQL spec coverage or not, and then we'll see how to improve further. Okay. In terms of next steps, the code is extremely messy right now. I was barely able to make everything work. So yeah, refactoring and code quality is something that we would need everyone's help on. We want to actually move from a custom parser to an actual parser. An actual parser looks a lot different, and we'll get into the mechanics of how to write an actual parser. Or like we can see some other parsers, and we can get away with that as well. So we can directly use an actual parser. Don't have to actually get into reuse of stuff. We also want to get into caching for queries. What it means is, right now, every time you do a query, a CSV is loaded into memory. It's unloaded into the memory once it's done. So we don't want to do that. We want to figure out which queries are happening, which queries are there in the queue. So if you have like 500 queries in the queue, which are for the same table, we would actually want that table to be in memory entirely. Okay, so this is something that we'll do. And of course, we still want to do this challenge. This is a 1 billion row challenge. We want to figure out how good StylusDB SQL can do. So outside of loading, if we just have to figure out how aggregates work, or how fast aggregates can work in StylusDB, we'll have to get into the depths of stuff and see how good we can do. Okay. Right. Any questions, I'll stop sharing now. Any questions?
Yeah, just clarifying something. Do we still have only strings as types, right?
Right now, yes. And we are planning to move away from that. So now that we have Prisma to actually manage different types of um, different types. So what we want to do is we want to get that data from Prisma to StylusDB and start managing them in the same way that it should be managed.
Mhm.
Yeah. So we want to move away from string as the only type, but it was a good starting point. I don't think it can last longer. I mean, it has lasted for 2 weeks. That's the max a string can last. Yeah. Right. So Prisma is one of the most famous JavaScript ORMs out there. I it is currently the most famous one. So we're just trying to figure out how to get into the community. So Prisma supports like 5 databases right now, and we have just added one in a week or so. So that's so yeah. I mean they've done a brilliant job in supporting adapters as a construct, and this is something that we were able to use in a very quick time. Cool. So as a hands-on, I would like everyone to implement whatever I've implemented. And what you can do is you can just go through the slides again and try to implement each one of these features. There's something that will just broaden. It will push you a little. Actually, it pushed me quite a lot. How to think about stuff, how to read documentation where it's not available. So Prisma adapter documentation is not available. So all you have to do is just have to go through the code again and again to actually figure out what each function is doing. So yeah, that's a kind of exercise that's a very rewarding exercise to do, and I believe everyone should do that. So just go deep into code, and then only you'll be able to implement this. But yeah, any thoughts on what we should be picking up next? Because I was hoping we can implement like a NoSQL database in the next session, similar to how we implemented a SQL database in this session. But yeah, open to thoughts. Dhruv, Radhe, Yesh, Dave, Priya. Yeah, anyone? What would you guys want to know more about in terms of databases?
Oh, actually, I'm curious about the user management stuff. Like there are different users that they have access to different parts of the database.
Got it. Got
Yeah,
it.
so
Got
that
it.
would be one
So
thing.
let me just add RBAC as a thing. Okay, we can directly implement RBAC now because Prisma supports RBAC.
Hmm.
So yeah, let me just look into this. Anything else? Anything? The floor is open now, so I don't want to continue just doing my own stuff. How many of you were able to do till steps 13? Kesh, were you able to close till step 13?
Yeah, I did.
Got it. Got it. Are you guys facing issues when moving ahead from step number 9, or is it just a lengthy process and that's why it's taking time? Are you blocked somewhere that you're not able to move forward from? Got it, Dhruv. Because I think I've moved. I also want to take a feedback on if we should go slow a little. Should go a little slower, or the pace is fine, because I see a lot of people will not be able to catch up to step 20 by end of next week, mostly because of scheduling issues and bandwidth. Any feedback on that front? Got it. What kind of practical examples, Radhe, do you think the older format was better, where we were going through the tutorials? Because the tutorials were, got it, fair enough. What we'll do is, the next session would be exactly like the previous session was. Okay. When we'll build on the internals of MongoDB, we'll only focus on how to build a NoSQL database. Okay. And we'll do this as a hands-on exercise in the class. Cool. I think this is it then. Thanks everyone for joining. I know the number of people are a little less, but thanks for joining. Yes, just share the recording in the group for people who would want to listen after this. Okay. Cool. Cool. Thanks everyone. Thanks for joining. Okay. Bye.